Hello everyone, welcome to your 10-5 lesson on secant lines and segments. Our learning target for this lesson, we are going to be able to use angle measures and segment lengths formed by intersecting lines and circles to solve problems. We will recognize and apply relationships formed by secants and tangents intersecting inside and outside a circle. And we will also recognize and apply segment length relationships formed by secants and tangents intersecting inside and outside a circle. So the new word you're hearing right there is something called a secant. So let's go ahead and put that vocabulary into our notes. A secant is a line, ray, or segment that intersects a circle at 2 points. All right, if we were to draw on some examples of that, I'm going to put arrows on the end. There's line, and I'm going to go ahead and say here's point A and point B. So line AB is a secant because it intersects the circle at 2 points. You can see it crosses through. So intersects and continues on. So we've got those two intersection points. We also have, could be a ray. So a ray has an endpoint and then continues in one direction with an arrow on the other end. So maybe this is endpoint C and it passes through point D. So this is ray CD with the segment with one arrow above. That is a secant. It's intersecting your circle in two spots, and one of them does continue on through. And then could be a segment. Here's segment EF. That's a secant intersecting the circle in 2 points. So those are three different examples of secants. All right, so we have a theorem to start with involving secants. The measure of an angle formed by two secant lines that intersect inside a circle, let's underline inside a circle, that's a key point here, is half the sum of the two intercepted arcs. All right, so here's a picture of what we're talking about. We have our circle. We have two secant lines like this. They're intersecting. When they intersect, they form four angles. We're going to focus on angle 1 right here. When these lines intersect, you can see that we form 1, 2, 3, 4 arcs. But the intercepted arcs from that angle, so if this is angle 1 and we follow it out in both directions, we can see that it is giving us this arc X right here. Well, if we follow that line in the other direction, we can see it's intercepting the circle and giving us arc Y. So those are the two intercepted arcs that we just went over in that theorem. So if you have two secants that are intersecting inside the circle, so you're going to see us talk a lot about where's the vertex. The vertex of your angle is inside the circle. So the measure of that angle is equal to half of 1/2 times arc X plus arc Y. So when the vertex is inside the circle of intersecting secants, your angle that it creates is equal to 1/2 times the sum of those two arcs, one arc plus the other arc.